Good morning, everyone. Hope you are starting with a great morning and a good day. We'll take 2 minutes of time and then we'll start our session. So yesterday we have done with the introduction for the Python programming and animation with the Python, and we have basics of variables for the next topic. So actually this is so similar to the block level of coding, but there is a little difference. We have some syntaxes where we have to note them down. Some script, okay, some lines of code and all, it is a little different, so that's why we are recalling the session again. Anyway, the theory part, it is like all similar, but when coming to this, we have to note down the syntaxes of this. Anyway, so let's go into the session. So it is variables. Yeah, in this topic we are going to cover variables, data types in variables, arithmetic operations, addition, bot, and etc. So you know the same example as like before. I just want to repeat it again in a simple way. So variables is nothing but it's like a empty bowl, and you can fill any other value in that. Just like if you want to serve soup to your guest who comes to your home, you can and there are a lot of guests, and you can use the same variables to same bowls, clean them up and then serve the soup in the same bowls, right? So that's how a variable work. It stores the value. It's like it's something that can take or store different value or the program is executed. Just like the same bowl is used to store different things, a variable is used to store different values such as numbers and words. And why variables? Variables are important in programming because they enable us to write flexible programs. So in general, if you have a data, we're assigning one particular value to one variable, and the program should be written with a symbolic notation such that a statement is always true symbolically. If so, the syntax that we are talking about is something like this. For example, if I want to know the sum of two grades, we can write sum, which is a variable assigning to grade 1 plus grade 2 in a void. So the brackets indicates void. So in the scripting language, we write it like this, and the variable sum will then contain the sum of grades regardless the scores in the data in the variables in grade 1 and grade 2. So data types in variables, similarly, the same, these are all the data types: integer, float point, string, boolean. So all the expressions. Let's look at the syntaxes of them. So integer data type variable store only integer values. As you know, the stored whole numbers which have 0, positive and negative values, but not the decimal values. Just recalling the topic again. And here we have assigned A to number 2, B as minus 156, and print A and print B. This is how we write the script. And the output of the program will be 2 and minus 156 as we have assigned the values to the variable. Then we have example of declaring a float variable. Float point numbers are decimal values hold real numbers and decimal values. 2.5 minus 1.5. So here we put int 1.5 and it will give us the int value minus 1.5. And string data type. To extend the character of the data type, a user may have a requirement to store or perform operation on the sequence of characters. The string data type stores the value in the sequence of characters in string format. Example, I am stored to A, to B, stored to B, value 5 stored to C. So if I print A, B and C, I am to B, number C is 5. So that's how we store the string data type here, and it is denoted with the double quotations here. So you can see it is denoted with double quotations. Then there is a subtype of an integer data type called boolean data type, which stores the value in the boolean type only. So that is true or false. Example of declaring of boolean variable is a equals to 2, b equals to false. Print a, b, output true or false. True or false is boolean. And there are some rules, naming rules. Naming variables make it easier to call them while program the operations. The name of variables also suggests the information the variable contains. Below are some rules of naming variables. A variable name cannot start with a number. It must start with an alphabet or underscore. A variable name is case sensitive. Sum and sum are different variables, and variables can contain only alphanumeric characters and underscore. So arithmetic operations, you know the operators. Operators are the special symbols which represent the completion. So just like they are applied to the operand, which can be values or variables, and the same operator can behave differently and a different data type and hold the different operations. So operators are categorized as arithmetic, logical, reasoning and assignment operators. And yeah, the symbol plus indicates addition, and if you want to put in a print statement, print 60 plus 40, which gives the output of 100. Print, this is the numeric example, and this is this string type example. Print good morning, so it will give you. So, and anyway, every time we have to put double quotations where if you are using a string type data in any other print statement or any other assignment statement. So minus indicates subtraction, so this is the example, and asterisk is a symbol for multiplication. So good multiplied by 3, good multiplied by 3, and this backslash is division. Print 17 by 5. Double backslash is sorry, actually this is slash. Double slash is integer division, 7.0 by 2 point, and percentile, this is remainder or modulus. Modulus or remainder both the same, so we can use this one. And so it will give you the remainder of an division. And double asterisk is exponential, 2 to the power of 3, 2 into 2 into 3. So it's like the exponentiation of the value. 16 double asterisk 0.5 gives you 4. And the activity, the addition board, let's say enter number 1, enter number 2. I guess we did it yesterday. So Toby input number 1, input number 2, and then the sum of two numbers, that will give you the output like this. So let's do the program. 2557. So that's how it works, and this is a simple activity. So let's check the chat box. How many people are 24 viewers currently? Good morning, good morning, good morning. Yeah, very good morning all. So the concurrent views are 3.36. Average duration we have. Yes. So if anyone is copying the code, please. So I guess we can continue to the next topic, which is a quirky. So even this topic, the display emotions, you can do the same. We have some functions. So I guess yesterday we did the emotions with the quirky and conditions in programming. So we'll go with functions. Anyway, we did the quirky program. So yes, so now the topic is functions in Python. So in this topic, we're gonna focus on the mathematical functions, built-in function, and user-defined functions. So these are a little different from the block coding. So the properties of cube is the activity, and let's do it. And mathematical functions in Python. So a function is a block of code made up of a set of steps that results in single specific action. So function can be categorized as below, like modules, built-in functions, and user-defined functions. So start, do addition, input 15 and 20, output is equal to result 1, print result 1, do addition, input 20 and 40, output is result 2, and then print result 2, and add. So this is the flow chart. So here in the function we have created function block like this, function of addition. So here just we can just after starting the program we can just say do addition with these inputs. So and this addition function is already pre-programmed, and we are asking for the inputs a and b and the sum a and b and return to sum. So this is how the function will work. It's a separate block of code within the same program. And a module. So this is important. A module is a file containing Python definition and statements. Those are functions. So the definitions from the module can be used within the code of the program. It's just like creating a function and we are calling it in the main program. So once you import a module, you can you can use any of its functions or variables in your code. So import is the simplest and most common way to use modules in our code. The syntax of importing modules is import module name. So module is a file or one other extension where we can use it, create it predefined, and then we can use it in the program wherever we want to perform a particular task, right? And so there is an example of a module. So example, import math. So import math is a module in which we do the mathematical functions. Okay, whenever we are doing mathematical functions in Python, we do import math. So one execution of the statement, the Python will search for the file of math.py within the software and create a space where modules and definitions and variables can be created. So then it executes the statements in that particular module to use, access, invoke a function. So you will specify the module name and the name of the function separated by a dot. So it's like math.py. If we put import math, it's like math.py. So let's check. So this format is also known as a dot notation. So value of math dot square root of 25. Let's see one example in PictoBlock. So this is I can clear it out. So here we have the files, right? If I put import math function and run it, then I want value of math square root. So we are taking one variable called math and let's see. So here in the print statement we are getting the value square root of 25, as you can see in the left bottom. So this is called the terminal, and if you want to put it for say sprite dot say this one, the value. So that's how it takes. So here you can see in the modules there is one sprite and we have imported math function here, right? So this is how, and we can see about more examples in the next one. So I want to check the chat box. So it's this good morning and 37 views so far, 7 viewers. So if you have any doubts or the speed is like too much, please let me know. And these are a different math modules or the name of the functions which are predefined in the math modules. So we'll just let know it in detail. So seal is sealing, seal dot x. So x is a variable here. So it's something that it returns that smallest integer not less than x, where x is a numeric expression. So for suppose math dot seal, sealing value minus 45.17. So it returned to the 45. So it's a sealing value. And math dot seal 100.12. So it will seal it to 101. Math dot seal 100.75. So it will seal the value to 101. So it will take the upper value, the sealing value of the number. It returns to the higher integer. And then floor value. Floor value is nothing but for suppose math dot floor 100.12. If it is the value is different, so it will return to the minimum value 100 floor. So if you want me to explain in detail, I'll just take one whiteboard. So here, if I want to explain, there is some the if there is some pi value, so that is 3.1473, some random this value is there, and we are if we are doing floor of x, and it should be in small. I guess you can see it. Floor of x will be equals to some, and I also will take another ceiling value. So C of x is something that it will give you the value of 3.00 or 3.0, and the seal value is 3.1. For the same value, for this value, the floor and ceiling value are written like this. Yes. So then we have fab. Fabs is nothing but it returns the absolute value of x, where x is a numeric value. Math.fabs minus 45.17. So it returns to the same 45.17 and 100.12. So it returns to the absolute. And exponential. So exp refers to exponential. So it returns to the exponential of x, where x is a numeric expression. Math.fabs minus 45.17. So here the exponential value is 2.1500621326e. So this e minus 20, e plus 20. So we use it. So all these math modules we will mostly use in creating designs, creating games, or we can use it in creating some animations or the characters. So these math functions are not only used to calculate something, but also we can like while using the design, we can use all these math functions like logarithmic expression, exponential form, absolute value, ceiling and floor values, all these expressions. So we use these in while creating something, right? So yeah, now moving to the next one, log x. Log x, you know, the logarithmic form of natural logarithm form of x for x is greater than 0, where x is a numeric expression. So if we put math log 100.12, it will return to 4.60, and log 10x is the base 10 logarithmic form, where x is a numeric expression. Math.log 100.12, and it will give you the value of 2. And pow is the power of some certain value. So if we give math dot pow 100 2, it means 100 to the power of 2, and 100 to the power of minus 2, 2 to the power of 4, and 3 to the power of 0. So all these expressions, it returns the value of x to the power of y, where x and y are numeric expressions, right? And the square root, you know the square root, right? It returns the square root of x for x value is greater than 0, where x is a numeric expression. So math dot square root of 100, it will give you the value 10. And math dot square root of 7, and square root of 7 is 2.64575. And cos x, you know cos x, right? Cosine value. So it returns to the cosine of x in radians, where x is a numeric expression. So I want to ask you to search about radians and gradients in Python. So what, like in Python designing, so then you will have a little like knowledge about this thing. And math dot cos 3, so cos value of 3 is minus 0.989. And next we have sine. Sine is the sine of x in radians. X is the numeric value. Math dot sine 3, 0.14. Math dot sine minus 3, minus 0.14. Sine 0 is 0. For the tan value, tan x, it returns to the tangent of x in radians. Math tan 3 minus 0.14254, and math minus 3 is 0.14254, and math tan 0 is 0. And degrees is it converts an angle of x from radians to degrees, where x is a numeric value. So math dot degrees 3, 3 degrees means 1.71 radians. Math degrees minus 3 is minus 1.7188 radians. And radians is converts the angle into degrees. So it will convert angle of x from degrees to radians, where x is a numeric value. Math dot radians 3, 0.0523 is the value. Minus 3, minus 0.052. So radians to degrees, degrees to radians conversion, we use radians and this one. And we have built-in functions now. So in built-in functions, we have absolute is abs. It returns the distance between x and 0, where x is a numeric number. So abs of minus 45 from distance from 0. So distance will always give us in positive values, right? So distance can't be negative. 45. So because it's a particular value, right? So that's why it's not in negative format. Abs of 119 is also a positive value, not negative. So now max of xyz. Max of xyz is, it returns to the largest of its arguments, where x, y and z are numeric variables. So max of 80, 100 and 1000. So what's the maximum value in this list? 1000, right? So that's why it gave the output of 1000. And max of minus 80, minus 20, minus 100, which is the maximum value, minus 10. So that's how. And minimum of xyz. So it returns to the smallest of its arguments, where the x and y are numeric variables. So minimum of 80, 100 and 1000. So the minimum value is 80 in the list. So minimum of minus 80, minus 20, minus 100. In this minimum value is minus 80. So, and these are CMP XY. So CMP is nothing but it returns to the sign difference. The sign difference of two numbers. So minus 1 if x is less than y, 0 if x is equals to y, and 1 if x greater than y. So it just gives you the sign difference of these values. So if CAB 80 is and 100 are there, in these two values y is greater, right? So it will give the negative sign -1. If x is greater than y, 180 and 100, it will give you the positive outcome +1. So in round off, the round off is round x of n. It returns to the float value of x rounded to n digits from the decimal point where x and n are numeric expressions. If n is not provided, then x is rounded to 0 decimals. So x of n 80.23456 and n value is 2, so it will round off to 80.23 and round off -100 some 0056 in 3 value, it will return to -100 and round off of 80.23456 is 80.0. So it will take how many n number of the decimal points like after the dot, so it will print those many points. Composition. Composition is the art of combining two simple functions to build more complicated ones, and that is the result of function is used as an input to another function. And for suppose we have two functions f1 and f2, and a is fn2 of x, a is, and b is fn of 1, then the call of two functions can be combined as b fn1 of void fn of x. So this will be the input to the other function, right? So I'm storing the entire value to another variable here, and to define a function keyword def is used. So define is like something in a short form, it is def. So after the keyword comes an identifier, that is the name of the function, followed by a parenthesis list of parameters and colon at the end. So this is the syntax. He is explaining about the syntax of differential function. And next follows the block of statements and the part of the function. So block of statements is a block is one or more lines of code grouped together so that they can treat it as a one big sequence of statements while executing. So this is the syntax to define a function. So def, define, and name of the function. So name of the function here, it is say hello. Say hello, and creating a void, two parentheses and a colon. After that we have to give tab space. So this space is important while we are writing the script. That's called tab space. So that means the line of code, this line of code is within the defined function, right? So we are creating a void where we store the lines of code which belongs to the defined function. Print hello world is the second line of the same function. The first line of the function definition, that is the line 1, is called the header. So def say hello is the header, and the rest, the line 2 in our example, is known as body of the function. And the name of the function is say hello, and empty parenthesis indicates no parameters. So the body of the function contains one Python statement which displays as a string constant on the screen. So let's put it in our program. just to check. So it should be in parentheses. Maybe now it will work. Okay, this is to define and say print hello world is the same function of say hello. Then we have to call the function after. So we have to call this function after defining the function, right? So function call is like say hello. And now properties of a cube. Before going into the topic, I want to check the chat box once. World of games. So I want you guys to be ready with your systems to do this activity. So it's Python. So in this topic, we're gonna also learn about how uh, we have parameters and arguments in this topic. So parameters are the values provided in the parentheses when we write a function header. So these are the values required by the function to work, and the arguments are the values provided inside the function. So to call or invoke the particular set of function, the statement. A list of arguments should be supplied in the same way as parameters are listed. So bounding of parameters to argument is done. So it's 1:1, and so there should be the same number of types of arguments as mentioned in the parameter list, otherwise it will give you an error. So now defining the sprite object. So this is the syntax to define the sprite object. Sprite equals to sprite obby, you know it. Define the surface area of the function. The function will have one parameter as the length, and depth surface area cube of length, and it's calculate the surface area of the length cube. Then the surface area's formula is 6 into length into length. Okay. And this is the first function, because why 6 into length is because cube will have 6 faces, right? For 6 faces, and the surface area, one area of a square is length square. So length into 6, and now it will return to the surface area of the cube. Now defining the volume. So this function will have same one parameter as the length. So def volume cube length, it calculates the volume of the cube. So you don't need to use a hash code. It's just a comment. So this block of code is a comment. This is called a comment. So this doesn't have any value there. Volume equals to length into length into length, and return to the volume. So ask the user to the length of the cube. So just like ask block in block coding, we have the in sensing we have ask block, right? So that's like, similarly we have sprite dot input, enter the whatever this line, enter the side of the line, enter. So you can use any other word. So sprite dot input parenthesis is taking input. So L equals to int sprite down answer. So we are taking the sprite answer, the input from the input block, and we are storing it in the L. So this is L. L means length. And display the surface area. For this we have to write sprite dot say surface area is str, because it's a string. Maybe we can get a string value. Str surface area cube L. So surface area of cube formula we have already given in the function, into length, right? And volume is string volume of a cube L. So L value we are giving it in the function's name. So this is the parameter. So length is the parameter, and we are storing L value in the place of length. So this variable replaces into another length variable. L replaces into length variable. So that's how. And sprite equals to this one is the full program. I'm just going to copy and paste it. I'm going to explain while doing the program. So first block we are asking Toby, because we have selected Toby, this is the first master line. Then def surface area of a cube. So this is the function. Let's run it. The error is there because in the Toby you have to use single quotations. Of all these blocks you have to take care, and maybe it will run some double spacing. So first it is not returning here because all this set of block is just the setup. First it will directly go to the 10th line here, and it is asking enter the length of side. Okay, and first line, first is the 10th line, it is executing. So I am giving 5. After entering, after I press enter, it will go to 11th line and store the number 5 value in L. Then it will go to this one, surface area of length. So L value is stored, it put it in here. So 6 into 5 into 5. So it is 150. So yeah, we got 150, and here we have length into length into length. So 5 cube, which is 125. So the answer to the cube should be 125 volume, and 150 is surface area. So that's how we calculate. So in the iteration process, it will go like from here, it will start, and then it will go to this one, and it will go to print statement, sprite say block, and then again it will go to volume, and then it will go to print block. So this is how the iteration works. I'm gonna present the program for 2 minutes. If anyone is trying out, please type. Okay, if it is so this is, I guess this is visible, more visible. Yeah. If anyone is trying out the program, please, I'll give you present the program for 5 minutes. If it's okay. Okay, this is not visible. Okay, but only display. Yeah, you can do the program. If you're done with the program, please respond in the chat box. It's also live. If anyone wants to start, you can join. So only one contributor is there. So if you are done with the program, please respond in the chat box. I'm gonna continue. If you want me to present the same screen, I'll present it for 2 more minutes. Or if you want me to continue to the next topic, I'll continue. I'm gonna continue to the next topic as I'm not getting any responses here in the chat box. So this is the output. As you can see, we got the output like similar one. So the next topic is conditional statements in programming, and someone wants to join the meet. So yeah. Nazaf Sheikh, hello, good morning Nazaf. Okay, I'm gonna continue to the conditional programming here. Yeah. So in this topic, we're gonna cover this control flow structures, if else in Python. So here you will learn about the iteration. So how actually the program will iterate, just like in the loops and logical operators. And we have two activities. One is grade calculator and one is it a triangle? So control flow structure. So there are three basic types of control structures in programming. One is sequential, one is selection and conditional, and one is iterational. So first, sequential is a control structure. The statements in the program are executed sequentially. So like it's like a step-by-step order-wise program that they have written. So there's like one by one in a sequence. And now selection or conditional. So selection is a control structure is used to test a condition in the program. Like for suppose if the distance is this much, then open the door. If the value is equals to this, execute print the number, something like that. And this control structure takes a decision to execute one statement operation over the other statement operation depending upon the condition. And the iteration. So this control structure execute a set of statements a certain number of times till the mentioned condition is true. And the loops are the examples of iterative statements. And for example, if we decide whether a number is given even or odd by dividing the number by 2, if the remainder is 1, we can say the number is odd, right? And if else statement requires three things. One is evaluation statement, execution statement, and else execution block. So it is better if you guys are noting it down. So I suggest you to note down because it's maybe helpful for you to learn, and also it will be helpful as a reference notes for the exam that you're gonna have in the end of this month. So start, enter n number. Is n divided by 2 is equals to 0. So this is the evaluation statement. So this is this condition here. This is the evaluation statement. And this, if it is no, n is odd. If it is yes, then it is even. So if and else. So execution statement. So this is an execution statement, and this is else block. Right? So this is how it requires the evaluation, execution, and else execution blocks. And syntax of if statement in Python is if condition colon statements of block 1 and else condition statements of block 1. So if the condition is true, that is satisfied, the statements will return after if block like if that is the block of statements of block 1 is executed. Otherwise the statements will return else. It's like not satisfied. And it remember else clause is optional. Remember the else clause, you can put it like only if condition, if and then is there, if else and then is there, right? Here we have elif condition. So elif is nothing but if, else, and again if, then else. So there is a combination of if and else in one statement, then we use elif. So elif clause instead of else clause is something but elif is a combines if and else. If else statement to one if, elif, and then else. So you may consider elif to be an abbreviation of else if. Got it? So if condition statement block of 1, elif statement block of 2, else statement block of 3. And now we have an activity of grade calculator. So we have to define the TOBE and define a function named grade with parameter 1 marks. So def grades marks. So I'll save this project as so now the conditions are here to determine the grades using if else statements inside the function. So here if the marks are above 85, then return to A. If marks are greater than 70, return to B. If marks are greater than 60, return to C. If marks are greater than 45, return to D. If else the value is very less, return to E. So now this is how we can say sprite.say grade for 95 marks is grades 95 for 2 seconds. So this is how we are defining how many marks they have got and the grades are. So this is the program. I'll try to type it. Sprite says TOBE def grades equal to marks. So we are defining a function here called def marks in grades. In this, we are adding if marks are greater than 85, return to A. Okay. So if you press enter, it will automatically take this indentation. So this is one indentation, this is two indentation. This means the f block is inside the function and the return statement is inside the if block. The return. Okay. Now we have to give backspace so that it will be in the section. Now elif. 70, 60, 45. Someone wants to join. And if marks are greater than 60, then return. I hope everyone is following with me. And if else it is even less than 45, then it is return E or fail or whatever. So now we have defined the whole function. Now we have a block of statement like this. So sprite dot say grade for 95 marks is in the grades, and we are giving this value in the class. And for 75, so I'll put it so there are 5 cases, right? So for 5 cases we are taking 5 blocks. And for 76, so B something around 64. For 64 it is C grade, it should give us C grade. For 51 or we can ask the user input. 51 this, and below 40, which is 42. Let's run the program. 95 marks is A grade, and it is B grade, and this is C grade. 51 is D grade, and 42 marks is E grade. So that's how it will give you the output. So if you give the print option, usually in the Python, if you give print option, it will give you the terminal block here. So and this project is called grade selector. So I'll just put some backdrop. So so here you can also use take user input. Someone is asking to join. Yeah, you can't shake. So great. So then we have the next activity. It is for nested condition. Here I'll just present the screen. So we got 35 as a D. So we got the same output as this one. So now for the nested condition, so it is possible to have a condition within another condition. Such conditions are known as nested conditions. So here, if x equals to y, sprites say both are equal. Else, if x is less than y, sprites say y is bigger than x. Else, sprites say x is bigger than y. And here, sprites say case 1. So compare numbers is our definition here. Okay, I'll tell you how to write the program. And we have test case 2, test case 3. There are 3 test cases here. So let's run the program, and this project is called grade py. So for the sprite Toby, we are taking def compare numbers and x and y. Here we are taking and in this function we are taking the inputs of the condition if x equals to y, sprites say both are equal. X double equals to y, actually I want to copy this one, and I want to take one more sprite which is interesting one. Naruto character is Itachi. I want to take this some character as a sprite just to make it more interesting. I just copy or download the image in desktop. Go to this and add the sprite. So this is how we take the character. So this is our character, we can paste our the program. So till here it's saying, let's take it till here. Now then I'll add a background also. So this is how to add the backdrops. So just for the kids, they love these kinds of like interesting stuff, right? So I'm just this has been downloaded in some other file. Guess this on desktop. Yes. So let's select the backdrop. Upload. That is this PNG file, and I guess this is AVIF. So this won't work. JPEG, only JPEG will work. Something like this. JPG. This will work. Now it will fit in the entire screen. I'll put this character here. Now it is looking a little more interesting. So now, if x equals to x, then sprite say both are equal. Elif or if, so this is nested if. You can put elif or just if. So else will be here and if condition will be here. That's what. So yes, x is greater than y, print sprite say x is bigger number, comma, for 2 seconds. Then sprite say so this is how we have to maintain the indentation, the spaces between the program, so that will run better. For 2 seconds. So now we have return statement, because we have to, so, or I can just need to put it here, just put else statement inside the else block. Now, this is the perfect indentation. So in out, and then there is return statement. After this return statement, we have to take 3 test cases. So 1, 2, 3. So where the values are different. So the test case 1, someone wants to join the meet. So this is the case 1. Sprite say case 2, where this should be a bigger number, and sprite say case 3, where it will be a bigger number. Y should be a bigger number. Let's run. So the x and y, there is one problem in the else block. Expected in the else block it is there, yeah, now it will. So line 11 return is outside the function. Yes, it is outside the function. Maybe this is the correct one. Yes. Case 1, case 2, x is bigger number. Case 3, y is bigger number. So this is how the program is running. I'm just running again. Both are equal. X is bigger number. Case 3, y is bigger number. So yeah, I'll present the program again. If anyone is following the program. Sir, there is a problem with volume cube function. Sorry, Javed sir, I didn't see the message. So what is the problem? It is running. Should I present it again? You can just go back and check, Javed sir. So you can just go back in the video and just check where is the problem. So if you guys have any doubts, please, Javed sir, can you please reply if the previous program problem has solved or not? Otherwise, I'll just present the program once. Okay, sir. Thank you. Thank you for replying. So then solved. It's okay. So if anyone has completed this project also, I will just close my session for today. Yeah. So if anyone have any queries, please let me know in the chat box. I'll wait for 1 minute. Thank you. So same problem. We'll try again. Some problem. Some which in this program or another program. Mumtaz Khan. Same problem, I guess. Okay. Okay. Please try again. So thank you for your valuable time today, guys. Yeah, maybe it is just the indentations, ma'am, Mumtaz Khan. So maybe it's the spaces between the program. Yeah, thank you for your time. I'm gonna wind up the session for today. So I guess I hope we have finished the 3 sessions of Python. I hope you all understood well and try to follow. And the next class will be started by 10:45. So we'll be on time. Thank you so much. You can have a break of 15 minutes. Thank you.
Google Meet is over. Is Google Meet over?
One. Welcome back to our session Cloud Computing. I hope you are there. Good morning. Okay, so without wasting our time, let's get start. So I just want to know anyone completed your presentation? I just want to know that anyone is ready with your presentation. So today we'll do one thing. We'll do a recap of yesterday's session, and then we'll move on to a practical session. So let me know how many of you have laptops or any desktop. Any one of you have laptops and desktops? How many of you have? Okay, I'll put this in the chat box, Google Meet link. So I'll pin this. So we'll start Google Meet also, but before that we'll move to the recapping of yesterday's lecture. So before that, I want to know how many of you have laptops and desktops, because today we have a practical session today, so that should be done in the laptops or desktops. So anyone is ready with your laptops and desktops?
I have
Okay.
laptop, sir.
So before that, we'll do one thing. So we are going to start with our session. Okay, so whoever have laptops, they can do it practical. So whoever doesn't have, just observe that how the things are working, so that you will also have hands-on on that. So before doing that, we'll start with recapping. So yesterday we have done something called virtualization. So we learned about what is virtualization. Virtualization is a technology that helps the hardware to divide it into different parts and work as a virtual softwares. Okay, so we also learned how we use virtualization. So virtualization is different types. So we use something called hypervisors. So we have two types of hypervisors. One hypervisor, type 1 hypervisor and type 2 hypervisor. And type 1 hypervisor we insert on the hardware, and type 2 hypervisor we insert on the operating system. I'll show you with the practical how to do. Okay. Yeah. So let's see that. So we have one hardware. Okay. So this is hardware. So on top of this, we use something called hypervisor. So this hypervisor is type 1 hypervisor. So this how this hypervisor works means, this hypervisor helps to divide the hardware system to use multiple operating systems. to use multiple operating systems. Okay, so this is type 1 hypervisor. So on top of the operating systems, we also, let's say this is a whatever we are using, whatever I am using, this is a operating system, Windows operating system. So in this Windows operating system, I am using multiple applications. Let's say this is one application, and this is one more window, this is one more window, and I am also using this is one application. So type 2 hypervisor will be placed in the operating system. Type 2 hypervisor placed on the operating system, which helps us to open multiple applications. So these are the two types of hypervisors. So we also learned something called how it works. Means, let's say we have two different architectures. So this architecture is without a virtual machines or without a hypervisors. So in this we can do with the hardware. This is the hardware. With the help of this hardware, we can use only one operating system. In this operating system, we can use only one application. Whereas when the virtual machine comes into the picture, when the hypervisors are placed, so the type 1 hypervisor is placed on top of the hardware. So when it is placed on top of the hardware, this hypervisor helps to divide the hardware into multiple parts, not two parts, multiple parts. Okay, so once it divides the hardware into two parts, let's say we are using one more operating system here, and we are also using one more operating system here. So this is using two operating systems on same hardware. When the type 2 hypervisor comes into picture, the type 2 hypervisor is placed on top of the operating system. Okay, when the type 2 hypervisor is placed on top of the operating system, this type 2 hypervisor helps to divide the operating systems to run multiple applications. Is it clear? Yes, is it clear? Anyone please respond. Is it clear? If it is clear, I'll move on. Okay, so I hope it's clear. So we'll move forward. What we have done yesterday is we learned something called type of virtualizations in cloud computing. We can do virtualization of servers, we can do virtualization of applications, we can do virtualization of desktops, we also do networking, and we also do storage. I hope this is clear what we have discussed yesterday, class. Please respond. Any doubts till here? If there is no doubts, we'll move forward with the practical class today. If you have any doubts, we'll clarify it and we'll move forward. And later we'll have presentations in the Google Meet. So please join the Google Meet. So I also explained how the server virtualization works, how the application works, networking, storage, and desktop works. I hope this is clear. Anyone from the Google Meet, is it clear? Okay, if it is clear, we'll move forward for the practical. Please open your laptops. Please open your laptops. If you open your laptops, I'll show something. We need to install few things. Okay, once you open your laptops, type VirtualBox. VirtualBox. Remember this. You should know what is the configuration of laptops or systems. If it is a 64-bit, click something virtual 64-bit. If it is 32-bit, click 32-bit. Okay. So once you click on this, the first link you have to open. Are you following? Yes, everyone open this. Once you open this, you'll have a Windows host, because see, there is two different things, host and the virtual thing. So whatever the system we are using, Linux or Windows or Mac, whatever the thing we are using, we have to choose that as a host. So now we are using Windows, so we choose Windows host. So see, this VirtualBox is downloading. Okay, once you download VirtualBox, again go to other tab, go to new tab. So I request one thing, if you join the meet, right, if you have any doubts, you can directly unmute yourself and you can ask. So that would be a very good thing. You can also share your screen, or you can do whatever the errors you have. So you can unmute and you can share your screen and you can clarify doubts. So once open a new tab, click something called Ubuntu. Ubuntu 32-bit, download. The first link we get, download Ubuntu desktop. We also have something called Ubuntu server. Now we are using it in a desktop. So go to the first link. So here we have a multiple versions of Ubuntu. So I request you click on this. You're following, right? So you click on check out other alternative downloads. So once you click on this, it will take you to the new tab. So once you go to the new tab, here we have a multiple Ubuntu options. Slowly go forward. Here you have something called Ubuntu 22.04. Okay, so please try to download this. Once you click on this, so yeah, that's what I told. We have a server image, we have a desktop image. So we are using desktop image because we are downloading and we are running it in the desktop. So click on desktop 64-bit image. So it is almost 5 GB, I think. Yeah, 4.7 GB. So it will take some time. So give some time for that. It will download. You are following? Who are in the Google Meet or who are in the YouTube live? You are following, right? So give some time for that. It will download. Everybody started downloading? Have you downloaded the VirtualBox and you have started Ubuntu? Anyone? Please respond. Have you started downloading? Okay. Okay. No worries. So whoever is able to download, do that. So I hope at least you try to see what we are doing here, so that you'll get an understanding of what's going on. Okay. So until this downloads Ubuntu, we'll do one thing. We'll install VirtualBox. So we have downloaded the VirtualBox. So just double click on the VirtualBox. Okay, in the downloads we can see VirtualBox. Double click on VirtualBox. Once you double click on that, click on next, next, next. Yes, install. Please follow this. Click on install. Are you following? So once you click on that, the VirtualBox is installed. Everybody got this screen? Everybody got this window? I'll keep it full screen. Okay, it will take more 10 minutes, I think 5 to 10 minutes to download Ubuntu. So until then, you got this screen. Everybody downloaded. If you are facing any issue, please come to the Google Meet. If you share your screen, I can help you to download that. So you have to download the things based on your system configuration. Can anyone tell me what virtualization is this? What we are doing? What virtualization is this? Yes, from the Google Meet or from the live. Can someone tell me what virtualization we are doing here? Yes, anyone? What virtualization is this called? downloaded your Ubuntu? Have you done installing? Anyone done? So this is how the virtual what Oracle VirtualBox looks like. And everyone able to see my screen? Okay. So this is how the VirtualBox looks like. So once we download our Ubuntu, I'll show how to configure the Ubuntu here. If anybody is facing any issue, please if you can join the Google Meet so that I can help you when you share your screen. Now you are unable to see. Now it's visible. Okay, cool. So okay, I'll show you VirtualBox. So you are able to see VirtualBox, right? Okay. Anyone downloaded Ubuntu and VirtualBox? Have you downloaded VirtualBox and can you share your screen? Are you doing it in the mobile? Okay. Can you join through the laptop? No, ma'am. It is very high-end configuration, so it is not possible in the mobile. So no problem. I'll show you how to work, how to do, so that you'll get to know how it is going and everything. Yeah. So once we'll clarify her doubt, what is her doubt, so that we can move forward. Yeah, ma'am. You can join through the laptop and you can share your screen. So yeah, so this is what the Ubuntu is. So in the Ubuntu we'll download desktop image because we are running that in the desktop image. So we are downloading the 64-bit PC mode. So once that downloaded, we can use it in the VirtualBox. So tell me what type of virtualization this is? Anyone from Google Meet or anyone from YouTube Live? What virtualization we are doing now? Yes, anyone please. What type of virtualization we are doing now? We have discussed few virtualizations. So what type of virtualization we call this? Desktop virtualization. Okay. Is anyone else? No, Javed, that is not correct. That is correct, but a part. No. Using two different operating systems on one hardware device. That is what we are going to do now. So okay, she is not there. I think we'll move forward. So everybody able to see my screen, right? Okay. So moving forward, once we open the virtual box, it looks like this. So here we have something called new. Once we click on new, here you have to configure your number, whatever the name you want to keep it for operating system. Okay. So now the operating system I'll keep 1 2 3. Okay. So now I'll put operating system 1 2 3. So we are going to use Linux because we are using Ubuntu. Ubuntu is a Linux. So we'll click on next. So here see, so now what we are doing here, we are virtualizing our storage, virtualizing our RAM and storage. Is it clear? So this is the total what we call the memory size we have for this system in the hardware. So how much size we want to give it for our virtual machine? So we are giving 2048 MB and we'll click on next. So use existing virtual hardware disk. So once we click on here, we have something called open files. You are following? Anyone? You are following? Who are all doing this virtual box or virtualization? Are you following this? Okay. So once we click on here in the downloads, we have an image file. One second. Yes. Okay, Ubuntu 22.4. Okay, we'll do one thing. I'll delete this. So I'll try to install 64-bit because this system is 64-bit system. One second, give me a second. Okay, so we'll go for here 64 bit. Okay. Yeah, now we open the 64-bit virtual box. So here we have something called new and add. So whenever we want to add a new thing, we click on new. Here we'll give a name for virtual mission. You are now able to see screen. Everybody able to see screen? Okay. So now we clicked on here. So here there is something called iOS file image. Okay, iOS image is nothing but the operating system's image what we are going to give. We call that operating system images as iOS. So we'll click on files. So in these files we have that in downloads. This is the iOS file we downloaded, Ubuntu 22.0.4. We'll click here. Yes, the file is there. Okay. We click on next. Here let's see, these are the usernames and passwords. Okay, these usernames you can change it however you want. So make sure this you remember. Okay, you're following anyone? So please follow this. So once you click on this, username and password you gave, and the host name is 123, the username is 321. So we click on next. Here, this is where we virtualize our hardware. So here we have a 8 GB processor. We have, I think, 1 TB what we say storage. So here we can change our storage or however we want, and the processor also we can change. So we are putting here 2 cores and 2491 MB of memory. So once we click on next, so everything is there. So the storage is 2 TB. We are giving 25 GB for virtual machine. Click on next. So let's see here. These are all the few things which you named here. These are all the things where the virtual box is stored, where the iOS image is stored. So this is the iOS image where it's stored, and this is the virtual box where it's stored. This is a mission name we have given. This is the username, and we have given passwords. I hope you are following. Anyone? Please, anyone? Oh no, ma'am. Because you'll phone maximum you'll have how much GB of RAM storage? It will be 256 or 128, I think. Maybe. Yeah, but still with 128 GB or 256 GB, we can't do these two things because this is made for desktops. If you use desktop mode in the your phone also, the storage will not be enough. So your phone will hang or sometimes it will crash. Yeah. So you can follow this. I think you can follow this. You'll know how it is working. Yes. 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 Change it. Change it. Yes. Not any file. What the OS we want. So this Ubuntu is a OS operating system. So not everything whatever we want we can't install. We can't upload it to the image. So we have a few operating systems like Windows, Mac, Linux. Yeah, these are all the operating systems we have. In this Linux operating system, Ubuntu is a one type of operating system. So yeah, we need to upload this operating system image. Once we download, that will be as a image. It looks like a image. So once we upload this, we configure everything like username, passwords, everything, and we have we discussed something called hardware virtualization. We use one physical hardware where we run two operating systems, more than one operating system. Yes. So what we are doing here, we are dividing our storage from the physical hardware storage. We are dividing 2491 MB of storage. We are allocating to our virtual machine, virtual operating system. And the processors, we have I think 8 GB processor here. We are giving 2 GB processor for virtual machine. And the disk. Yes, how much we want we can give, but the thing is, make sure your physical device will have a more processor or more storage, because if you want to run this virtual machine softwares, the hardware should be strong. Yes. So these all things will, once we configure, we'll click on finish. So our virtual software is installed. So yeah, so now however we do our normal desktop or normal Windows system, will turn off, turn on, sleep, switch, power off, power on, these all things we'll do, right? So the same way we can also do here. Yes. So here we'll have these things. I'll show it once these all configurations are done. I'll show it. Now our Ubuntu VirtualBox is working. So this is one OS, and the Windows which are running on the base, that is one OS. So we are running two operating systems on same physical hardware. So this is, yes, Ubuntu is one more OS. So we are virtualizing our hardware into two different operating systems. Yeah. So it will take some time to install. Whatever it takes whenever we are newly installing our Windows, the same thing will happen in the Ubuntu also. We'll give some time. We'll wait for a few minutes. And is everyone following this from the YouTube or from the Google Meet? Whoever is doing, if you face any problem, please let me know. I'll clarify your doubts. Okay. Yes, please. Is your system 64-bit or 32-bit? Okay, then don't download 32-bit. Delete this and download 64-bit VirtualBox. Go back. Okay, here you clicked on 32-bit, right? So instead of 32-bit, you type 64-bit. Go to system settings, and there you'll have about your system, so you'll know. Maximum laptops are 64 only. It's okay. Download 64-bit. No, cancel this 32. Instead of 32, place 64. Ubuntu you have downloaded? Yeah, show me Ubuntu tab. What you are downloading? No, we are still able to see only VirtualBox screen. Share your full screen, not only one window. Stop sharing and again share whole. Yeah. Now you share whole screen. Entire screen, yes. Yes. Now go to Ubuntu screen, window. Yes, it is downloading, I think. Yo, okay. Until then, you download 64-bit VirtualBox. Yeah. If you can do that, you can follow me so that it will be easy for you. So these all things are installing here. Whatever the operating system base files are there, so everything will be installed here. So this is how the Ubuntu looks like. This is the desktop. What we say, desktop of Ubuntu. Here we can see time, date, everything we can see. Once it's installed, I'll show. Whenever you are making it, you need to make sure you enter your password. Anyone else following this? Anyone else doing this? Or if you're not doing, or you following this, how we are doing, what I am doing, how I am creating virtual machine? Anyone? Okay, So here see, let's see here all the things it will show, whatever we can use it here. These all things it will show. We'll just move forward. So here the files are copying. So once the files are copied, we can move forward. Are you following this? Anybody? Are you following this? What we are doing here? Yes, who are in YouTube or who are in Google Meet? Have you downloaded 64-bit VirtualBox? Okay, after downloading, please install that VirtualBox. If you can share your screen also, it will be good. 1 second, it is still not. Yeah. So it is 32-bit, no? I told you to install 64-bit. No, download the old one. Delete the old one. Delete the old one. Use the new one, 64-bit. So I hope you are able to see. You are able to see my screen. So this is how the window. This is how the Windows looks like. Sorry, this is how the desktop of Ubuntu look like. Yeah, we'll wait for some time because the files are copying. Anybody has any doubts till now? Anyone has any doubts? Yes, Mumtaz, you have completed? Have you downloaded? Okay. Anyone else doing? Sohail, Zakir, Sajida? What about you, Javed? Are you doing this? Yes, yes, videos are available. Videos are available in the YouTube. So yes, these will be available. Okay. We don't get any information that classes will be cancelled or something. I think classes will be move as usual. If you want, you can directly go through the YouTube and you can search there. Okay. Delete the old one. Delete the old one. 5.2. You delete it. 5.2. Use 7. Go to file manager. File manager. Yeah. Delete that. Yeah. Now install the 7.0. Okay. US is not 64-bit, ma'am. You said US is 64-bit. No, I don't think US is 64-bit. I think US is 32-bit only. Yes, this is not 64-bit, ma'am. No, you have to use 32-bit only. So whatever you downloaded it will not work. So delete the 7 point, use 5 point only. Yes, use a 5 point, yeah. Use it that only. Yeah, click on replace. First one. Yes. So you can see whatever the things are present in the hardware desktop, everything will be installed in the virtual machine desktop. Yeah, just restart your system now. Okay, now click on new. Yes. Okay, type some name for the system, operating system, some name. Yes, click on next. Yes, next. Now click on third one. Yeah, click on file. Go to downloads. You're able to see Ubuntu. Have you downloaded Ubuntu? Okay. So open the virtual box. Or restart, ma'am. Restart your system. Then only the configurations will be set down. Yeah, again you have to open it. So for the setup, it will take some time whenever we install the virtual machines. So if everything setup is done, so that it will looks like a Windows only. Yeah, stop sharing, ma'am. Stop sharing your screen. At least write down the steps to follow so that it will be easy for you whenever you try to install this. At least note down if you are not doing it here. Okay. Everyone do that. It will help you. So you are able to see that bottom one, right? Everything, whatever the things are, files, hardware, everything is installing in this virtual machine. So whenever you don't want this virtual machine to run, you can just power off your virtual machine, then the storage will be back to your hardware. So if you don't want to use this virtual machine, you can directly delete it. So that is how you can do. So if you do you have any doubts on the topics what we have discussed and the Ubuntu installations or something? Yes, anybody have doubts? So, how to install the Ubuntu, how to install the VirtualBox. So whenever you are installing, make sure that which configuration your system is, 32-bit or 64-bit. I'm sorry. I'm sorry. Yeah. I got out of Google Meet. Yes, tell me. Yeah. Yes. Please. Yeah. So go to downloads. Okay. Yes, Ubuntu. Yes. Open. What is the error? Okay, I think which version you downloaded the Ubuntu? 64-bit or 32-bit? Because your system is 32-bit and the VirtualBox also 32-bit, right? So okay, try to download 32-bit now. Yeah, because the configuration, whenever you are configuring, right? So whatever the VirtualBox we use, 32-bit or 64 VirtualBox also. I think VirtualBox is 32-bit. Yeah, then download the 32-bit Ubuntu. I'll share my screen. I'll show what is the click 32-bit. No. Go back. Here Ubuntu, yeah, 32-bit. Click on that. Okay, click on alternatives. Check off the alternative downloads we have, right? Top. Yeah, here only. Here you can download 62-bit. Yeah, there. Check out. No, not that one. Check out bottom one. Yeah. So go down. Wait. Go down. No, don't that. Not that. Go down. Try to install 20 or 18. So I think that will work. That versions. Yes. Try to download 18. So you delete this 22 version. Yeah, top one. Oh, this is 64-bit. No. This is also 64-bit. Okay. I'll see here. I'll search in my desktop. Okay, 18.0.4 is the 32-bit we have. So you can see my screen. Are you able to see my screen? You stop your screen. You stop sharing your screen. Yes. Now it is visible. I think now it is visible. Now. Yeah. See, 32-bit Ubuntu 18.4.0 download. Here we have 32-bit Ubuntu. Yes. You are able to see, right? We have 64 bit and we have 32 bit. Are you? Yeah. See the screen. Yeah, you type this one, 32 bit Ubuntu 18.0.4 download. So in that we have a 32 bit and 64 bit processor. Yeah, in this you will get a 32 bit image. So that is what, whenever we are downloading the things, we should make sure that how our system configurations are 32 bit or 64 bit. So based on that you have to download, because sometimes the systems will not support for the high configurations. So this is still running, this is still installing. So yeah, we'll wait, we'll see. Any other doubts? Anyone have any other doubts? Why only she is responding? No one has laptops? Okay. Samira, Zakir, Sufia, you don't have laptops or desktops? So once this installation is done, I'll show you how it looks, but it is taking a lot of time. So now what we are doing here, we are making a storage virtualization. We are using the same storage and same processor to run two different operating systems. So Ubuntu is one operating system, and the Windows is a one operating system. It will take 5 minutes, maximum 5 minutes it will open. Yes. Are you able to see? Are you able to see my screen? Yeah. You can directly skip this or move forward. So these are all things we can use in this virtual machine. So I'll show you. Okay. So I am using two different operating systems here. Okay, so let's see, this is one operating system I am using, and here also I am using one more operating system. So I can do two parallel things in two different operating systems. This is Linux, this is Windows. In this Linux I opened a Chrome, and in this in this Windows I opened Chrome. I am working on different things, and also in this Linux I opened Firefox. Yes, you are able to understand, right, what is happening here? No, it won't, because this is separate operating system and this is separate operating system. Both can be done parallelly, but the storage and the RAM were splitted into two parts. Few RAM and few storage is given to virtual machine, which is Ubuntu, and few are given to Windows. So no clashes will be happen with both. Yeah, any doubts? So here we can open files. We have files. So we can do whatever we want here. Everything like a system, Windows. So here we have music. Okay. Here we use Google. So yeah, there can be a multiple operating systems. We can use more than one, because in the virtual box itself we can use multiple operating systems, but if one is on we can't use one more. So once we switch off only we can use. So here we have something called close. So here we have a different options, right? Are you able to see? Power of the machine, send the shutdown signal. These all things we are able to see, right? So once we click on power of the machine, this virtual machine will be closed. The Windows machine will work as usual. Again we want to open this. We'll double click this. Here, powering virtual machine. So which means we are switching on the virtual machine. So whenever you are running two different operating systems, so your hardware will work more, because you are using now the power on, because if the power on, the operating system runs. If the power off, the operating system closes. So again if we click here, power off, it will close. Here powered off. If we double click here, again it will power on. So we can directly close this. Our Windows will be as usual. So now what we are doing here, we are using one hardware, which is, see, I have only one CPU, but I am running two different operating systems. So we are dividing the hardware to use multiple operating systems. Virtually we are using that. We are not physically using this. Yes? Clear? Okay, if you download the 32-bit, follow the steps what I have told. Give the name and add the image of 32-bit Ubuntu, and move forward with selecting your configurations. That will directly install. Yes, anyone have any doubts? You understood, right, how the virtualization works? Which hypervisor we are using there? We discussed something hypervisors. Which hypervisor we are using there? Yes, anyone? Which hypervisor we are using there? We are using type 1 hypervisor. What we discussed here. Whatever we discussed here. Is my screen visible? Okay. So whatever we are using, now what we are doing is, I have one CPU. Okay. This is hardware. So in this we are using type 1 hypervisor. Type 1 hypervisor to use this single hardware to run multiple operating systems. One operating system is Windows I am using, and the one more operating system I am using is Ubuntu. So these two are different operating systems which are running on same hardware. So we are using type 1 hypervisor. Yes, Sajida, hypervisors divides hardware into multiple operating systems, but which hypervisor? Type 1 hypervisor. Clear? Is it clear? So this is got virtualization is where we use the multiple operating systems for one single hardware system. I hope clear. Any doubts? Okay. So if it is clear, can we wind up the class? Yeah. Yes, Javed. Any doubt? Yeah. Okay. Yes, Javed, because let's see, whenever we have a hardware, we are dividing that hardware to run multiple operating systems. So what will happen when the hardware is configurations are less? We want to run more than one virtual machine. Whenever we are dividing hardware, the hardware will divide into three parts. Let's say we are using three operating systems. One is host operating system and the two are virtual operating systems. So when we are dividing the storage into three operating systems, the problem is the sufficient hardware will not be there for the host to run the virtual machines. So there they will get a difficulties where sometimes the operating system will crash, or sometimes it will take long time to run, it will lag, it will hang, these things will happen. So whenever we have a more hardware configuration, we can go for more virtual machines. Yeah. So basically, whenever we buy the laptops, these CPUs or somewhere, so if we are using old versions of operating virtual machines, the configuration will be 8 GB and 500 GB of storage is enough. But when we are going for new versions, so to install the versions only, it will take a lot of storage space and it require more processors. So now the availability what we see 64-bit Ubuntu 22.4 or 22.2, it required minimum 1 TB of storage and 16 GB or 8 GB of RAM to make sure it runs smoothly. We can do it, but the thing is how smooth we are running it is the matters, right? So yes, exactly. Yes. So if you don't have any doubts, we'll wind up the session. Tomorrow, I hope you clear with virtualization. Practically also I showed you how virtualization is making. Mm, yeah. So tomorrow we'll meet with new topics. So yeah. So can we wind up? Yeah. Thank you everyone. So thanks for your patience. Thanks for your listening. So I hope you'll get some inputs from this hands-on experience. So we'll move forward and yes, Javed. Yeah, sure. Yes. So we have other virtualization. We discussed about network virtualization. We discussed something called okay. Okay. So here, see. So here the thing is, desktop virtualization means provides more flexibility of usage of more than one application. Let's say whenever we open one desktop, we are using one desktop. Okay. So we can virtually use two desktops where the same application can run. Okay, so give me a second. I'll show you practically how it is working. Mm, yeah, my camera is visible. Okay, so I'll show you practically. So this is one desktop we have. Okay, and we also have one more desktop. So where we are using two desktops to run the same applications. But the CPU is one. We have one CPU, but the desktops are two. Clear? Clear? Yeah, is it clear, Javed? Yeah. So whenever we see practical things, right, then it will be very clear for us. So that is the reason I showed you practically how it is working here in the studio. Yeah. So if you don't have any doubts, we'll close. I'm winding up. So tomorrow we'll meet with new topics. Yeah. Thank you. Thank you all.
Guys, hope you are there in the live session. If yes, please do respond. To some network issue. Yeah. So for yesterday, due to some network issue, we were not able to complete the topic, and I guess you have not even heard about the introduction into the topic. So let's start this topic once again. Today we are into cryptographic primitives. So what are these cryptographic primitives? See, cryptographic primitives are like the basic building blocks of a security protocol or a system. Like they provide us the base and the foundation for the security protocols which need to be maintained in our system or a device. Okay, not device, you can say it as a protocol or a system. Protocol is nothing but a set of rules which you need to follow, like the way you work, the way you do, the way the system and the technology needs to work. It's like a set of rules. So to build security on that type of protocols and everything, we have cryptographic primitives. Okay. So today we are going to see what are cryptographic primitives, types of cryptographic primitives, that is what is keyless primitives, what are symmetric primitives, and what are asymmetric primitives. Am I clear? Please do respond, guys. Cryptographic primitives refers to a fundamental building block or algorithm used in cryptography. Can anyone tell me what is cryptography? Please do respond. Okay, so these primitives are like building blocks or something that let us they provide us a secure environment so that we can trustfully use those online platforms to transact for transaction purpose or some other external factors. Okay, these primitives serves as the foundation for constructing more complex cryptographic systems and protocols to design more secure systems. Yeah, good morning. So to construct more complex cryptographic systems and protocols, these primitives are used. Am I clear? Of cryptographic primitives do you think we have? We have three: keyless, symmetric, and asymmetric. In these three, we nearly have 8 methods. Okay. So these are the methods. In keyless, we have random numbers and hash functions. In symmetric key primitives, we have secret key ciphers and MACs. MAC stands for Message Authentication Code. And in secret key ciphers, we have two more types. Those are block ciphers and stream ciphers. And in asymmetric primitives, we have digital signatures and public key ciphers. So, what are these primitives? The first one is keyless primitives. Keyless primitives refer to cryptographic primitives that operate without the need of secret keys. So basically, we need some keys to unlock, encrypt and decrypt our data, right? So what does this keyless primitives does is, without the need of keys, they have two methods. What are those? Hash functions and random numbers. Using these two methods, the keyless primitives is being operated. Am I clear? And the other one is symmetric primitives. Algorithms that use the same key for both encryption and decryption. Okay. In this, the key which is used for encryption the data is only used for decryption of the data also. The key should be established and must be agreed upon some information exchange between the parties. Like, exactly right. So you can't decide what it is. When two people are using the same thing, the confirmation from both the parties should be there. Am I clear? So for that, the two parties should exchange some information and they should be agreed upon that. The key here should be kept very secure. So it is a secret key cryptography. Okay. So this symmetric primitives, or the keys which are used in symmetric primitives, are also known as secret key cryptography. Here some are also, see, here keeping a key to ourselves is known as a secret, but here we need to share our keys, right? The same key needs to be used by the sender as well as by the receiver for encryption and decryption process. So that is known as a shared key cryptography, which is a perfect where symmetric cryptography comes into act. Because in symmetric primitives, we need the same key to encrypt and decrypt, right? So it is a shared key. You need to share that key information. But whereas in asymmetric, while encryption, you need to use the sender's private key to encrypt the data, and at the receiver side, you can use your public key for the decryption of a data. It involves a pair of keys. So asymmetric primitive is also known as a secret key cryptography. Am I clear? We use some public and private keys, right? So instead of this public and private keys, what are the types of keys we have? We basically have three types of keys. One is temporary, static, and a master key. Am I clear? So there is another name for temporary key, that is ephemeral. Ephemeral keys are also known as temporary keys. Then what is the use of this ephemeral keys? The first one is ephemeral keys, or you can also say it as temporary keys. Am I clear? The second one would be static keys. The third one is master keys. What are the keys? Ephemeral keys or temporary keys, static keys and master keys. Am I clear? So what is the use of this ephemeral keys? So these are known as temporary keys which are used for short time duration, such as in a single session. After that session, you are not authorized to use that key. You can say that that key is been decomposed. Am I clear? See, if I want to send some important messages and I want that messages should be seen only once, some confidential information, I am sending it to my subordinate or to someone. If he opens it once, even the receiver should not be able to view that again. Okay, that type of keys are known as temporary keys, which are used for only one session. One session means encryption as well as decryption. Am I clear? For this is, in our WhatsApp, a new feature was added, view once. Okay, even the receiver can view it once, and the after receiver viewing it once, you can't view it again. Like, am I correct? It is the most secured one to share some confidential photos. That's where this type of ephemeral keys or temporary keys are used. The other one is static keys. Static keys are meant for longer period of time, like our normal purpose. So if there is a situation where, see, okay, let's take an example like where I am running a business. Okay, it's just an example, so you can link this example to the topic. I am running a business and I got a client message that we will be sending you some resources and you need to use that resources to build the project. So what they are gonna do is they will keep some like credentials for us, so that we can have access over that resources. See, at only once we can't withdraw all the resources, right? At some intervals of time we are going to withdraw the resources. So there is a frequent opening and closing of that resources, right? We can't say opening and closing. In technical terms, we can say that there is a frequent usage of the resources, right? At that time, this type of keys comes into play. Usage of key can be done for a longer period of time. Am I clear? Please do respond. What is the use of master key then? We have temporary keys, we have static keys. Then what is the use of master key? Respond in the chat box. Master key is a type of key which can be used to encrypt, decrypt, and the main usage of master key is to generate the key, other keys. So what does the ephemeral and static keys does? Those are just for encryption and decryption, right? So this master key is used for encrypting the data, decrypting the data, and also for generating other keys. So what are the three keys? Ephemeral keys, static keys, and master keys. Ephemeral keys or temporary keys are just there for single session or a shorter span. Static keys are there for longer usage or longer run. Master keys which are used to generate other keys. Am I clear till now? How do you think these keys will be generated? There are three methods which tells how you can generate other keys. Okay. So the first one would be random. Random is like where a random number is used for key generation. I think you heard yesterday or not, I said about a random function in Python, right? It is the same way. We generate a random number for the generation of keys. And the second one is key derivation function. Key derivation function. What is this key derivation function? It is like a algorithm that derives one or more secret keys from a secret value such as a master key or password using a pseudo random function. What is that function which we use here? Pseudo random function. Sorry guys. Am I clear? So it creates key using a secret value. See, in hash functions, how do you derive a hash value? There is a mathematical calculation that will be going behind, right? It is also in the same way. In the same process, using some random number such as the master key or some password, we are going to derive some keys. That is another way for deriving. That is another method for deriving the keys. Now, what will be for the third one? It's a key agreement protocol. Key agreement protocol. Term only you can like say what is key agreement protocol, right? It's like where two or more parties run a protocol that produces a key which is then shared between the participants. Am I clear? So based on the protocols which we done, the two parties come into an agreement. They come together, they research, and they, in the last, after the analysis and everything, they come together and then they try to generate a key. And that, because that key should be shared with the receiver as well as with the sender. That is known as key agreement protocol. Am I clear? These are the three methods with how you can derive a key. So let's go back and see each cryptographic primitive in a detailed and easy manner. With which we are dealing is keyless primitive, and in keyless primitive we have random number and hash function. Am I clear? So randomness is an essential element for the security. It is mainly used for the generation of keys in an encryption algorithm. So it is like a random number will be generated. Okay, let me delete everything. C. Okay, yeah. Okay, now this is our blockchain, and now I am using keyless primitive. Okay, so as sender, receiver, yeah, sender, receiver. P stands for plain text. And after that, encryption will be done on the sender side and decryption will be done on the receiver side. Encryption and decryption. After encryption, what form does the plain text takes? Ciphertext. So conversion of the plain text, by encrypting the plain text, we are converting the plain text into a ciphertext, right? Here also the first step which we get is a ciphertext. After ciphertext, it will be decrypted. After decryption, we will get our plain text. Basic communication between two parties takes place. I will write it here. S is for sender, R is for receiver, E equals to encryption, and D equals to decryption, and C equals to ciphertext. Is that okay? So this will be our major how it goes, right? So what is the first one? What is the first one we are dealing with? In keyless primitives, we are dealing with random function. So how does the encryption and decryption will be done is, we will get a random number generated with the setting range from 1 to infinity. We can get any number, 4, sometimes it can be 4, 3, 2, 1, even it can be 0, right? So what happens with that number? As we have seen how the key is generated, we have in key generation we have 3, right? Random, key derivation function, and key agreement protocol. The first one is random. So using that random number which is generated, the encryption will be done, and that random number will be sent to the receiver and also for the process of decryption. Am I clear? So after the conversion of the plain text into ciphertext by the encryption method, we are going to send it to the receiver. The ciphertext, with the help of the random number generated, will be decrypted and sent and will be converted into the plain text. Am I clear, guys? Please do respond. So this is how the random function works. Do you think we have only one? In random we have 2. First one is like the normal, like how the random number is generated and how it works. The second one is pseudo random number generation. One second. Let's keep it aside because this is what we're gonna need for our future sessions also. So the second one is pseudo random number generation. It is the perfect example which I can give for pseudo random is our OTP. So basically pseudo random is nothing but, in random number only one number will be generated, right? But in pseudo random, a set of numbers will be generated for us. it's going to be like 1, 2, 3, 4. Set of numbers will be generated for us. Using this set of numbers, our encryption and decryption works. Pseudo random number generation are deterministic functions that work on the principle of using a random initial value called as a seed. Means we need something to start, right? So here the starting point is always known as a seed, the base one. It is known as a seed. One second. We have a starting one, the base foundation, which is known as a seed. Using this seed, our random set of numbers are going to be derived and generated. These set of elements are used to generate keys in encryption algorithm. See, now we have two, right? Random number and pseudo random number. Which do you think is the best and affordable for us? Affordable means on which we can rely a lot. Pseudo random numbers are the one which is more secure due to their reliability and deterministic nature. With the feature they present and the deterministic nature, pseudo random numbers are the efficient one for us. Am I clear? Guys, please do respond. Now the other one in keyless primitives is hash functions. We have completed the random numbers and now we are moving on to the hash functions. So what is hash actually? What are hash functions? Hash functions are keyless and they provide data integrity service. See, in cryptography we need three things: confidentiality, integrity and authentication. Right? What is the confidentiality in cryptography? If we are sending any message, it needs to be a little bit confidential so that no other person or the third party person can come and interpret the message. Right? So confidentiality should be there. And what is integrity? How can we tell integrity is required for us? It is like the assurance that the information modified will be done only by the authorized persons only. See, if you are running any business and if you are containing any information with us, only the authorized person should be able to change that. No matter what, without the authorization and access of the official persons or the important persons, we should not be able to change the information or edit the information. Am I right? If anyone can come and edit any information, what is the use of that? Right? And the third one is authentication. What is authentication? It is like a check way for us. It provides assurance about the identity of an entity or validity of a message, right? So if anyone is entering or if anyone is doing anything, they should be verified first. Without any verification and something, we directly can't let any person to access our things, right? Let's take an example of a social media platform only. I know everyone will be using Instagram, so let's take an example of Instagram. I have my username and password, and what if someone else tried to log in into that? Someone, my friend, wants that account, right? If there is no authentication, he can directly go into my account. He can do whatever he want. See, like, disobeying authenticity will let both confidentiality and integrity go down. Am I right? So authentication plays the major role for us. Am I clear? Guys, please do respond. So these hash functions also provide integrity service for us. And what are the other services, like other features that this hash function contains is pre-image resistance and second pre-image resistance. These two are the other features which our hash function provides us. These are known as security properties. These, with the explanation of these two, we can get to know like how hash function is very helpful for us. Okay, so yeah, this is the message I want to send it to my friend, and after using hash function over that, I will be getting a hash value. See, hash value can be a combination of alphanumeric numbers 5, 9, A, B, 7, 0, Y. So this is how hash value can be. I am not saying that this is the exact hash value for the message hi, but something like this will be generated, right? This process, okay, this process is, once again, this whole process is known as pre-image resistance. Am I clear? The mathematical formula, how you can say what this, the way you can represent pre-image is, let h be the hash function. H is going to be and capital H will be the hash value, and M stands for message, right? So now how you can display this in a mathematical form? See, this is the message, right? What I need to do, I need to apply hash function over this message, right? Then I will get the hash value. Simple. This is known as pre-image resistance. Am I clear? C for second pre-image resistance or weak collision resistance. Okay. Yeah, so this is my message and this is my hash value, right? HELLO. And if I apply hash function over to this, okay, let's not go to this far. He, instead of I changed it to he. I just changed one letter. Will you say that, will you think that the whole hash value will be changed, or a letter, or there will be a small change in it? What do you think? See, I just changed only one letter here. The hash function will be same, everything will be same, but I just changed the message in which I want to send, and in that message also I changed only one letter. Do you think there will be a small or a slight change in that? No. The answer is the whole message, which the whole hash value which will be done after doing the hash function will be changed. Some random numbers, okay, some random numbers will be generated again. There will be no significant change in that. So there will be a significant change, that is a huge change. Even if you change a letter or anything, even a small change can lead to a whole new hash value. Am I right? This is how hash function works. The technical process of how a hash function works. Now, sorry. Now tell me, if, first suppose, let us think that I got two same hash values. Will the message will be the same? Like, see, the two hash values which I got was 5610 439. This is one of the hash value I got, and this is another hash value which I got. That the message which I gave will be the same, or will it be different? Guys, please do respond for this question. It's important. The message which has got the hash function done and the hash value obtained like this, m1, let m1 be the first message, and m2 be the second message. If the, see, I have got two same hash values, right? Do you think that the message will be the same for these two hash values? Like applying some hash function on a message will drive it to get a hash value, and I got two same hash values. So do you think that the message which I have done, which I have want to send, will be the same or will it be different? On m1, that is h, I got this one, and applying hash function on m2, I got this one. Do you think this both messages will be same? No. Even if the hash value is same, the messages won't be same. See, for same message, if I do the hashing, I will get different hash values. Okay, let's, oh yeah, this is the sender, this is the receiver. We can even get the same hash value for different messages. I send a message hi to my friend. The hash value I got will be something, and after some time I sent again hi to the same friend. The hash value will be different. In the both their cases, the hash value will be different. That is case number 1. Now let's take another case. R messages sent, but here the case is I got the same hash value. Will the messages would be the same or different? It would be different. This concept of getting same hash value with different messages is known as the concept of where I am getting the same hash value for different messages is known as secondary pre-image resistance. Am I clear, guys? The normal process is known as pre-image resistance, and where the two hash values are same but the message inside it is different is known as secondary pre-image resistance. Clear with the topic of hash function? this secondary pre-image resistance in the mathematical form that goes as, one second, I will go for text only. So yeah, M1 will not be equal to will be not equal to here, yeah, will be not equal to M2, where M1 and M2 are two different messages, but the hash function of M1 will be equal to the hash function of M2, right? This is how mathematically you can represent secondary image resistance. These are the two main features of hash function, and this is how it provides security and trust reliability for us. This is how it provides us integrity service. As I said before, it provides integrity service for us, right? This is how, with the help of this secondary and pre-image resistance and secondary pre-image resistance, we will be secured using this hash functions. Am I clear? Keyless primitives are done. Now we are going into symmetric key primitives. What are symmetric key primitives? Key cryptography is also known as symmetric cryptography or shared key cryptography. Why it is known as a shared key cryptography? Because the sender and receiver shares the same key. That is why it is known as shared key cryptography. It is also known as symmetric cryptography. In this, the key which is used for encrypting the data is only used for decrypting the data. So how this will be done is, the key should be established first, and then the two parties should get agreed upon that by sharing some information. See, if you and your friend are planning for a trip, right, then you two need to sit, decide and come on to a single agreement, like where we are gonna go, what we are gonna do and everything. Am I right? The same thing goes in symmetric key primitives. Where the two parties should agree upon the key establishment, and then that key will be used for encryption as well as for decryption. In symmetric key primitives, we have secret key ciphers and MAC, right? MAC stands for Message Authentication Code. Before going to MAC, let's see what is block ciphers and stream ciphers? The first one is block ciphers. With the term block ciphers only, we can know that a block is getting ciphered. Cipher is nothing but conversion of plain text or a plain thing into an unreadable form and or unrecognizable form. Okay. So what is this block cipher in actual and how is it useful for us? Let's go deep into how this block ciphers work. Let me delete everything. Yeah. So as usual, not hi, let me take a longer message so that it will be helpful. Hello. What does is block ciphers are encryption algorithm which are applied on the blocks that we can know by the term block ciphers. How does it happen? This encryption will be done on blocks which are of equal size and fixed size. So what takes place is the whole message here which we are having will be converted into blocks. Each block will be of same size or a fixed length, no exceeding or no decreasing of the length. How the length and everything depends on the platform which you are doing, right? Or the environment, the virtual machine which we discussed yesterday, it is capable of dividing this into blocks. The best way for explaining this is in computer networks. How we know that the information is being transferred? There is a concept known as packets in networking system. That is, the whole information will be divided into packets, and that packets will be reaching to the receiver system through many ways, right? In the same way, this message, hello, good morning, will be divided into equal set of blocks, and the inside capability of the blocks will be the same, and that blocks will be ciphered. So the whole block will be encrypted. That is known as block cipher. As you can see here, block ciphers. So dividing the message into equal length of blocks and converting that blocks into unreadable or unrecognizable form is known as block cipher. As simple as that. But also remember, there are some ways in which this can be done. So those are electronic code book. One second. So the first one would be electronic code book, or ECB. Okay, and one second, I think two in bullets, electronic code book or EC. The other one is cipher blockchaining. Okay. First one is electronic code book, the second one is cipher blockchaining, and the third one is counter node. The fourth one is key stream generation mode. Stream generation mode. The third one is cryptographic hash mode. These are the main and foremost used methods for dividing the blocks and ciphering that blocks. Am I clear? In electronic code book, what happens is, in which see, there will be a set of blocks. Am I right? So from one block to another, the encrypted data which is produced as the output after applying encryption algorithm will be added as an input to the other block. I will explain that in a detail. One second. So what happens is, see, we are gonna have a blocks, right? These are encrypted blocks. One is an encrypted block and other is the different blocks which have been created using our plain text. See, we are not just developing one block, right? Based on the length and the size which we fixed, the blocks will be divided. Let us suppose that 3 blocks have been divided. After giving the key here, whatever the encrypted data is there, this encryption algorithm will be acting as the key to the other one. This will be our public key or private key, whichever we are using. And here will be the encrypted data. Sorry guys. encrypted data which will be acting as a key. To the other block. Second, what happened? Guys, just give me 1 second. Encrypted data as key. So yeah, this encrypted data will be using as a key for the this block. Understood? Now what happens with this block is, see, now the first block is encrypted using the key, and that encrypted data will be used as the key for the other block. Yeah, now we are back on track. So this data will be encrypted right now because we got a key which is the encrypted data of the previous one as a key to the next one for encryption. Now this data is the encrypted data. This block has also been ciphered. Now what about this block? Already the encrypted data in the second block will be acting as a key to the third block. So we only use one key for encryption, and the first encrypted data will be the key for the second block for encryption, and that second encrypted data in the second block will be used for encryption of data in the third block. Like that, that process continues till we reach the last block. That is how in electronic code book the conversion from plain text to the ciphertext takes place. Am I clear? Yeah. So let me give you a clear picture with a diagram. This is my plain text. This is another plain text, and this is another plain text. Okay. Here the encryption of my data will be done using electronic code book. Okay, how it will be done? Using key. The plain text is encrypted now. So it means that the plain text has been converted into a ciphertext. Now I have another like the block here. What about this? I need to cipher or convert this one also. How I can do that is, this encrypted data which is there will be acting as a key for me. Am I clear? Understood? This encrypted data is a new key for me now. After that, it will be converted into a ciphertext. Perfect. Now I have this last block with me. The encryption, how the encryption will be done here? The second encrypted data, whichever the second block has done, that will be acting as a key, not the first one. The first one act as a key only till it reaches the second block. The actual block needs a key from its preceding block. That is what you can say. The preceding block's encrypted data will be acting as a key to the present data block. After this, after the encryption, it will be converted into cipher text. Now this whole cipher text will be transported to the receiver. Understood how the block cipher works? Guys, please do respond. If anyone has any doubts till now, you are free to ask. That to be revised again, please, you are free to ask that also. No doubts? Okay. So the remaining topics, that is stream ciphers, MACs, digital signatures and public key ciphers, will be discussed in the next class, that is tomorrow. Okay, I will wrap up the session now. Anyone has any doubts? Yeah, you can ask me. I will be here.